Okay, let's look at this example. Find all of the places where the graph of this curve has a horizontal or vertical tangent. So tell you what, let's do before we do the calculus part. Let's look at it on Desmos. Now this is the curve that we're looking at. X squared or x cubed plus y squared equals a minus 2y. Now depending on what a is, the curve might look a little different. Let's bring this down so we can see more of it. See, when a gets big, this thing widens out. When a hits -1, notice instead of having a little bump on it, it changes to a cusp. And if a is just very slightly smaller than that, the bump is smaller. Now, if we let a go below -1, so let it go from -100 to 100. If we come back here, instead of a bump, it's just sort of a curve. All right, so let's go back and figure out where does this thing have a horizontal and where does it have a vertical tangent. Well, keep in mind, horizontal tangent means horizontal means y prime is 0. Vertical means y prime is undefined. So let's go through and take the derivative here. All right, derivative of x cubed is 3x squared. Derivative of y squared is 2y times y prime. A is a constant, so derivative of a is 0. Derivative of minus 2y is going to be minus 2y prime. All right, let's move this over to that side. So you get 3x squared is minus 2y prime minus 2y prime. I'll tell you what I'm going to do here. Instead of just factoring out the y prime, I'm also going to factor out the -2. So factor out the -2y prime, and I'm left with 1 minus y. And so when I solve for y prime, I get 3x squared on top, and -2 times 1 minus y on bottom. Actually, that should be a 1 plus y, because I factored the negative out. All right, so answering these questions, when the tangent is horizontal when y prime is 0. So if you set this whole thing equal to 0 and solved, it would wind up being equal to 0 when the top of the thing is 0. So it's horizontal when x equals 0. Let me change to a pen so that'll stay. So horizontal when x equals 0. It's vertical whenever the denominator is equal to 0, because in order for it to have vertical tangent, the y prime has to be undefined, and that'll happen whenever the denominator is equal to 0. So set the denominator equal to 0. When you do that, you get minus 2 times 1 plus y equals 0. So you wind up getting y equals 0, or y equals -1. So vertical when y is -1, horizontal when x is 0. And if we go back to our graph, we can see that. Let's see, when x equals 0, that's going to be, along the axis. So that's going to be here at this point and here at this point. Both of those have a horizontal tangent. For the vertical tangent, that's going to happen. Let me zoom in a little bit. That's going to happen over here. Let's see. That's going to happen when y is -1. Let me scroll up to that. It's going to be vertical. I'm trying to cram it in there. Vertical when y equals -1. Well, let's see. That's going to be here. Y equals -1. So, and sure enough, we've got a vertical tangent right there. And notice that doesn't change. If I move the a around, it's always got a vertical tangent when y is -1. And notice the horizontal tangents that it has when it has them always happens at the line x equals 0. So anyway, that's the answer to that question. All right.